So let's just go through all of the energy. Let's go through the energy transitions in this problem. So we're going to be way up here, right? So at the very beginning, so we're going to define our H equals 0 at the lowest point. So at the very beginning, what kind of energy does she have at the top? Okay, all gravitational potential. So we'll just say UG. So she has all UG at the top. As she's falling, what's the UG turning into? Kinetic. So all along the way, she has both UG plus kinetic, all the way, all the way, all the way. Now, what about at the equilibrium point? She still has UG plus KE. Okay, it's not all KE at equilibrium because we're calling this 0 down here. So she still has both. Now she starts compressing. What's going on here? What does she have like in between the equilibrium and D? All three of them. She still has potential. She's still moving. And now it's starting to compress. So she has all three types there. And then it's slowing down. She's losing kinetic. She's also losing potential. It's moving to the reference. And then what does she have way down at the bottom? All spring potential. So I went through the whole transition just so you know, well, if they ask at different locations. But all we really care about for this problem is the very beginning and the very end. So at the very beginning, she has all UG. And at the very end, she has all US. Okay? Let's finish the problem, and then if we have time, we'll get some questions. So at the very beginning, she has all UG, and at the very end, she has all US. And then we'll just go from there. So our equation for UG is MGH. And our equation for US is 1/2 kx squared. And again, we're going from the very beginning to the very ending. Okay, mg. Now, which h are we going to use? Okay, so the h, this is our h, all the way from our bottom, what we're calling our bottom, and our top here. So what are we using for h? 0.5 plus d, right? So that total height is going to be the d plus the 0.5 up. Okay, that's going to equal 1/2 2,000 times, now what is x? D. Okay, so that's the setup. That's the physics of the problem. The rest is just going to be algebra to finish it up and find D. So what's this? 40 times 9.8. Let's distribute this out, plus 40 times 9.8 D. Okay, looks like we're going to have a nice quadratic here. 0 equals 1,000 d squared minus 392d minus 196 0, right? So then you're going to, what are we going to do? Well, use your quadratic equation, okay, or your calculator. H equals 0 here. You could set h equals 0 here. Then here, though, you still have, it would be UG equals US plus UG. You would still have some UG, negative UG going down. Okay, I need some help. I can do some things in my head, but not this. 0.447? 0.6 what?
I didn't get that.
The other periods we're getting this, so I'm kind of leaning towards this.
What?
Well, if you do the 0.44, then you did the IH on accident, because I forgot the UG and the 6.
Six what? Okay, those of you getting .443, you did it wrong somewhere. So check your work. By the way, with the quadratic, you have two solutions, plus or minus, or no, it's not plus or minus, but there is a negative answer. But since we call this our h equals 0, our d is going to be a positive, so you would choose the positive value when you did it.